Did you know that a quiet revolution in Bitcoin mining infrastructure is happening across Europe? Miners are increasingly integrating directly with energy systems, helping stabilize electric grids, monetize surplus power, and reuse heat to warm homes and buildings. In this episode of the HashLabs podcast, Janis Varkals from Power Mining explains how this new generation of mining infrastructure works and why Europe may be leading the next phase of Bitcoin mining. Hello, Janis, and welcome to the HashLabs podcast.
Hi, Aran. Glad seeing you.
Can you introduce yourself?
Yes, more than welcome. So I am Janis from the company Power Mining. We are based out of Latvia and been in business since 2017. Mostly, it has been from the infrastructure perspective. So the name of the Power Mining comes from that it was a mining company, then a hosting company, then the energy crisis in Europe a few times in a row, which led us to be the infrastructure guys now. So we are probably top one, top two company in Europe for manufacturing and providing infrastructure for all sorts of Bitcoin miners. So air-cooled, hydro-cooled, heat reuse. Also these small miners. That's our latest project, actually. It's probably a lot of people don't know it, but it's a consumer retail Bitcoin home miner. A lot of people call it home lottery miner because of the Bitcoin algorithm, how it works. And if I'm not mistaken, last year, like 5 or 6 people managed to find a block with solo miners. So it's basically at that last year's pricing, it was more than 300,000 non-KYC Bitcoin in your cold wallet if you did it correctly and not on exchange.
Yeah, that's cool. And you donated a BitAxe to me as well, and I used it a little bit, and then I gave it to my brother. I'm not sure if he actually is using it, but I really hope so. And you also donated one to Alan recently, so I know that he's using it. And so for all the listeners, if you want to learn more about mining in practice, then these BitAxes are really cool gadgets, and you can use it at home, and it just consumes a little tiny bit of electricity, and it gives you a chance to actually get a whole block for yourself. So Janis and Power Mining are selling these devices if you're interested.
We're also manufacturing. So the interesting part is, so these are the open source. That's what we started with, and we felt the market a bit. This year, we already have our own R&D team because all the previous open source devices were based on Bitmain chips, but it's kind of, you should have several weapons in your arsenal, right? So people should have some choice with which company they want to support with their chips. So now we have the R&D for basically all other chip manufacturers except MicroBT. We even got, I think, Intel chips. So an old generation, not successful, inefficient ASIC chip from, there was a donation from the US entity. It was also open source, I think. So Open Source United, something like that. Excellent. So we are playing around because in here, with these devices, efficiency is basically not the crucial part as it is on the industrial scale. So you can just plug it in and, you don't care if it consumes 10 watts, 20 watts, or 25 watts. In industrial case, it's huge difference. The 25% consumption difference is huge. But per one chip, you don't care really.
How does electricity actually enter a mining site?
You as a miner, you know it as well, but let's put it like that. So you've got the electrical grid, which is, it consists of several power producers. So you have solar, maybe you have some gas power plants, nuclear power plants, hydro power plants. So all of that comes together into this beautiful network of what we call the grid. And then in order to get the electricity from the grid, you need that transformer, which then transforms the electricity to something that your devices consume in order not to burn down. And that's that part, that's the low and medium voltage, and then we're building high and medium voltage, and then we're building everything below that. So Bitcoin miners, let's assume rough numbers. These air-cooled devices consume roughly 3 to 3.5 kilowatts per hour. In comparison, it is something like your home heater, if it is, the oil one that you can plug in, it's roughly about 2 kilowatts of power consumption. So the miner is almost 1.5 of those oil heaters that you can plug in your home socket. So it's quite a powerful device. And that is just one miner. You have to take into consideration that we're talking usually about megawatts, meaning that we have to build the containers, so the enclosures for these miners at a bigger scale. And we do it in usual standard sea shipping containers. So, and then we install it. Let's start from the smallest, which is 20-foot container, which is half a truck. And that is roughly, depends on the miner, but 500 to 600 kilowatts an hour, which normally would be sufficient to heat up something like a pretty decent shopping mall during harsh winter. That's roughly amount the power that we are dealing with on Bitcoin mining scale. And the biggest part of it is the power density. And because when you have the cables coming from the transformer and then together you have this small distribution panel in your home, right? Where you open the small box and you have the breakers, which says, hey, this is my bathroom. This is my sockets on the second floor.
If you use the water boiler and the microwave at the same time, you have to go into that panel.
Yes, in a lot of cases. So what we have to do is build those distribution panels so that the electricity that comes from the transformer is directly split or properly split to something like called PDUs, something like this, power distribution units. So there are a lot of sockets where you plug in the miner, and then it distributes the electricity proper down to the miner level. And the fun fact here is that while we were focusing throughout these last years on Bitcoin mining and the power requirements from Bitcoin mining in a small area, which is 20-foot container, we had something like 600 kilowatts an hour consumption. Now with the hydro-cooled miners, which is way more powerful, which as well, it is like 10 kilowatts a unit or on a turbo mode. But let's assume 10 kilowatts a unit. So you've got 20 miners per rack. Those are 200 kilowatts. This is something that nowadays AI industry is just aiming for. So as we're all being focused on that, we actually didn't know that, hey, our knowledge of power density and cooling that we have accumulated throughout the years, it's actually very useful nowadays for the AI market. And they can't believe really that it's legit because it's Bitcoin data centers. What are they? It's not the serious industry, but I think time is showing now that the Bitcoin miners are one of probably important secret weapons for AI development. So Bitcoin miners had also, if we're speaking more globally, they had secured the power purchase agreements, which are now crucial for AI. Also, what happened now weeks ago, was it, in the North US? Around New York, where they had the snowstorm, right? So let's say Bitcoin miners had several hundred megawatts of power available, or they were consuming it for Bitcoin mining as a base level consumption for the network grids there. And when the snowstorm hit and they needed way more electricity than they anticipated, what Bitcoin miners did, they shut off the miners and the society gets the electricity which is needed at that point. So somehow, step by step, I think we're coming into the daylight a bit on several levels, which brings the society also some good. We can fast track the high density hydro cooling racks with cooling options. Then or not we particularly, but Bitcoin miners from the industry, they can secure the PPAs or have secured. And then again, they can curtail the energy when it's needed for society.
Yeah, it's very interesting. And what would you say is the most important factors to take into consideration when designing a mining site and deciding which equipment to procure for that mining site?
That's a good question. Usually our customers are the ones that are deciding on the particular hardware they want to use because they are differentiating in costs significantly. So let's say you have the PPA, so power purchase agreement, your kilowatt price is at 6 cents. That is just the electricity price, meaning that you have also some operational costs, which brings you to maybe 6.5, 7 cents per kilowatt, depending on the size and whatever. So at that price range, you're most likely aiming for most efficient miners. This is something that gives you bigger hash rate with less power consumption. And this is where then customer decided, he can't run old device or older generation miners in those cases. From our perspective, what it changes is maybe a slight model variations and some layout variations, but it doesn't change much because kilowatts and megabits on the network side are the same and the operations are not affected significantly. The biggest difference I would say is probably if we're deciding not in between machines, or miners, but the technology that you want to use. So is it air cooled, immersion cooled, or hydro cooled? And those are the biggest difference because they also differentiate in price, in their efficiency, and their use cases as well.
So would you say that it's fair to say that there are some design principles that have emerged from mining industry through constant innovation to reduce or to make it as power dense and efficient as possible and have as efficient cooling as possible? So there are some principles that basically all sites follow in the design part. And the main differences come just from the type of cooling technology employed.
So main side differences probably would depend on the scale, on the area, and the cooling tech that you use. Let's take, for example, the most popular one, the air cooling site. So air cooling, it does what it says. It's air cooled. It means it sucks the cold air from outside and through the chips, the air cools the chips down, and then on the exhaust side, it's pushed out. The principle is pretty basic, but then again, if you have those mining sites at scale, there are the air turbulences and also sound pollution, which then affects also the, let's say, living areas or residential areas if they are nearby. And now Norway's, and actually all the Scandinavian countries are pretty famous about complaints for all sorts of noises. It's a big challenge there, especially Norway also with their electrical standards. It's quite fun. You know how it goes, right? With the NEC 400.
Yeah, can you talk more about specifically from country to country? What differences are there in terms of infrastructure requirement for mining?
I can comment probably best about Europe and countries we have deployed the infrastructure in. So let's say we also have, I think, one container in Australia, maybe a few in the US, none in South Africa, but South America, but quite a lot in Africa. So we've got them in Kenya, in Congo, Tunisia, I think it's called, Ethiopia, Nigeria. So a few countries there, but so the least concerned about electrical standards are Africans. The most concerned ones are Norwegians. The least understandable, at least from our perspective, were the Australians. So that's why it probably didn't work out with us because we didn't bother discussing electrical standards for Australia. We didn't know about them, that they're different. We thought, it's an it used to be an English Commonwealth. So it should be pretty similar as Europe, right? But it wasn't. Swiss and Germany are, depends on probably, I would say depends on not only on the electrical standards in general, but also the use cases and where they are being connected and the local engineer. So you have some, like I like to say, you have the electrical guidebook, which is like the Bible. But then comes the local engineer, which has translated or understood it in this way, but you have manufactured in the way that you have understood it. So this is why nowadays we have a must-do procedure, which is we always ask first to confirm a certain configuration before we manufacture it. But
And
yes, the
how
standards,
how
yes.
difficult is it to comply with these electrical standards? Like, how big changes do you need to make in the infrastructure, let's say for a container, in the design and the components within that container? How like difficult is it? Is it like a completely different process to make a container for the US market than for Norway, for example, or Africa, or how does that work?
Yes, so it's not really difficult. It may, at least from my perspective, but there are some small differences, and those are mostly in the electrical components and their availability. But then again, most of it is determined by the customer and what they want. So how precisely their power meters have to be installed, or what kind of protocol they have to use in order to get that data out of the container. Small details like those. Like the largely electricity is pretty similar everywhere. Just maybe, the certification part is the one that differentiates a bit. Norway is different.
Yeah, Norwegians like to follow strict rules about safety. You can see it in the winter, like everyone walking with this vest, this yellow vest with this reflex to not be hit by cars. So yeah, Norways really care about safety.
So you're the only country that has a dress code on a country level.
Yeah. So what about I think when it comes to like Internet of Things and how you can connect the machines together, how the container reads the different data from the machines, that is extremely relevant for mining and is getting more and more relevant. So how do power mining do that? How has that changed over time in mining? Like, what is the optimal way to read data from machines and how power consumption in that container? Like, how do you do that?
So we can split it in several levels, I think, so people understand. One is the data that is coming from the Bitcoin miner, like the one behind. That is connected then to the internet, which is run through miner management software. And that is one part. The container part is it consists probably of humidity metering or humidity and temperature monitoring system, power meters. Those would be probably main things for the air-cooled container: temperature, humidity, and power. From those, you can determine a few things. Power meter, quite obviously, but from the, let's say, temperature monitoring system, you can quite easily understand or try to understand that when you have to change filters. That's a very common thing, because if the filters have clogged up and you have to change them, meaning that the temperature most likely increases because that the airflow reduces. Things like those. Humidity is good to have for information. As we are not always installing fans, then the pressure differences also are important in some cases. Temperature also is important when we, let's say, build it for Sweden, Norway, or Finland, and we make these closable louvers. So basically you can shut off the container and it shuts itself completely closed. What it brings is that when electricity prices are high, you can switch off the air-cooled container and leave a miner or two running still at minus 25 degrees if it's outside. So maintaining the warmth inside. So meaning that when you will have a price when you want to start hashing again, and it's still minus 25 outside, you can easily start your machines. It is minus 25 on the hashboard level, and hashboards are plastic mixed with metal parts, the PCB part. If it's minus 25, the plastic is fragile and cold, but the chip on top heats up very quickly, and it reaches sometimes 60, 70 degrees on the chip level. So the delta between the PCB and the chip might be at some points even 80, 90 degrees. So this is very important because at that point, when these huge temperature differences happen, they may break either the chip or the PCB, which means if you have millions worth of machines in the north, you don't really want to make them all gone in just one go. It's a very fragile thing in the end if those temperatures are low and high.
So how do you connect all of this together? Like, yeah, you can close off the container and run like one or two machines to like keep the heating a little bit inside. But how do you actually like connect all of that together in one system that you can automate based on, let's say, power prices? And how does power mining containers integrate with that? Like, how does that work?
So we have our own small, not the most advanced one, but it's very user friendly. An app, basically a cloud app where everything comes together, all the data. It's in beautiful graphs where you see temperature differences, you see outside temperature, you see the cold zone temperature. Cold zone is the one where miners suck in the air before, and then the hot zone is behind miners because miners blow out the hot air. So we've got several points of temperature monitoring, and that brings you the idea of, how you should, or when the miners are ready to be launched or started, how it all comes together. So as it's possible to connect through the API, then you can basically integrate all this data into your system or into your miner management system if it permits. When it comes down to electricity prices and how customers manage that, I'm not sure of all of them, but I know some systems have more automated or less automated systems where you can have set points of market pricing. So that means that system that you are using should be tracking also Nord Pool pricing if you are using the spot price. So that is one point. And then they also have to do a quick analysis when is it most efficient and when not. So it's a pretty complex system if you want to do it fully automated. Manually, it's quite simple.
Yeah. So if you want to do it automated, you need to connect containers through that API into your own system that you have created that also connects the miner management system that is again connected to the power market and can shut off the machine. So, okay, interesting. What is the main difference then between hydro miners and air-cooled miners? You talked about temperatures in the north. Like most people think that the only problem for mining is high temperatures, but as you said, very cold can also be a problem. How is that for hydro cooling? What happens if hydro miners get really, really cold? Can they freeze and be destroyed, or how does that work?
I think I can comment best on the projects we've done so far. So we are based in Latvia. We have some cold here, so we're quite familiar with cold and with snow as well. And few things there is that maybe not the manufacturers that come from south. They say that it's adjusted to cold areas, so that you will be using glycol, and that should be sufficient. It doesn't exclude situations where, let's say, you have downtime or electricity prices are too high to mine, then the whole container is shut off for, I don't know, maybe 5-6 hours. So at minus 20 degrees, it will just freeze through. And the problem with those miners is that the system for hydro-cooled miners is a bit more advanced, and it doesn't really allow the miners to start if the liquid temperature inside of those hydro-cooled miners is normally, they say, below 10, but we started noticing that we can start switching on some miners when the liquid temperature is at about +5, +7 degrees. So by saying that, I mean, if the container has, or the miners have cooled down to a level where you can't really start it up, that starts to be a problem for you and everyone that is involved in the business. So you have to heat up somehow.
I see. What about right now? What do you see in the market? Is it more moving to hydro cooling right now?
I would be glad to speak mostly about Europe, as we know it the best. US tendencies are not familiar to me. And so in Europe, it's two ways that we're noticing now, and they're pretty logical. One is not specifically like hydro cooling, but more heat reuse projects. And the other one for air cooled would be then grid balancing projects. And that is something that I think we have anticipated a few years ago with all these European Union green initiatives, which are green energy is great and definitely supportive, but it comes with some downsides, which is the instability. So at some points, when the sun shines, everybody, all the solar panels in that specific time are giving electricity to the grid at the same time, which most likely it's in summer and you don't really need so much electricity in the summer. So it's good, but you have to consume the electricity when it's produced, right? If you don't have the batteries. So that is one source. Then it's also wind. Same thing applies to wind production, and same thing applies to hydro production. Hydro, of course, is more stable. But then again, it also has some low times, right? And not always you've got the hydro accessible. So for air cooled nowadays, a lot of people in Europe are using the older generation miners, and they're not focusing on Bitcoin in general. That Bitcoin is a byproduct in those business cases. And they are more focusing on consuming the electricity at the time when the grid needs it. Because otherwise, the grid companies or your taxpayer money as a society, we would all have to be paying more for instruments that balance out the market. And this initiative is a private business to some people, and it benefits those people, but it benefits the society altogether when the grid is stable. The grid shortages have happened throughout quite recently. I think it was Spain, which took part of Portugal with it. That was because the frequency of the grid was not maintained well. Same thing was a few years ago in Texas when the grid came down completely because the frequency was not maintained as it's supposed to. So this is what the green energy gives or brings, upsides as well as downsides. And Bitcoin mining can be coming very handy into this because in comparison to even batteries, it's way cheaper. So batteries, let's throw out a number, $1 million per megawatt would be in batteries, roughly. With all the setups, cabling, site prep, it roughly would be about $1 million per megawatt. Air-cooled miners with older generation miners can be set up even at 150 to 200,000 per megawatt, which is like 5 times cheaper. Of course, they are older generation. They don't bring out a lot of Bitcoin, but then again, you as a businessman, you can charge from the grid the free electricity plus some fee that you are consuming the electricity when it's not needed for them. So it's give and take,
So in that case, in this type of mining model, you are mining with very low uptime, but the electricity you consume is either free or you actually get paid a little bit to consume it, right?
Precisely. And that is happening throughout, I think, all European countries. Like there's no one country that I can exclude. The programs differentiate, but the idea does not. So,
Oh, really?
and now when I'm seeing some advertisements from the US that they're selling like the old S19s, so the previous generation of air-cooled miners, I'm just thinking, let's bring them all in Europe, In every single country, there's a surplus at certain moments.
So have you seen, so there are actual mining projects in almost all European countries that do this grid balancing?
Yes.
So
And
Europe
I'm
has
not
more
sure.
mining than people think.
Yes. At a smaller scale, definitely. I'm not aware of if it's happening in all European countries. In not all European countries, Bitcoin is popular. But those are the initiatives that are coming forth. And yeah, we're noticing that for the past maybe 18 months already.
So is Power Mining participating in these projects around Europe with grid balancing?
We are supporting the miners by bringing the infrastructure, what they need so far. Let's see how this develops. But no,
And
so the incentive is not now to go into mining.
that is mostly air cooling, right?
Yes.
Because
Due
it's
to low
cheaper.
capex. Yes.
I see. And so what do you think about this market going forward? Do you think it's going to grow and we will see some substantial mining capacity in Europe in general? Because historically, most mining in Europe was in Norway or Sweden or Finland, and now it seems like it's kind of popping up a lot of small grid balancing sites in continental Europe as well.
Hard to tell, I can maybe just throw out some subjective things that I think might happen. And that one of them being now with this halving, that the block reward is at 3.125 Bitcoin. I don't know if you can put the halving schedule here for people to see, but then you will notice that, the block reward decreases by half every 4 years. For now, the block reward is 3 Bitcoin. That's nice to have. It's pretty predictable, but at some point it maybe not so far down the future, it might be in next or in another 2 halvings. It might be that the huge, large scale miners may not be sufficient to have just mining as a mining business. It's more likely than not that it's going to be some mixture of services that your company will have to provide. Either you will be the energy, you as a Bitcoin mining company, you will have to become an energy company, or you will have to be a service provider for the network, electrical network, or also the heating network, combining all of them. What I see is in the years coming now is that Bitcoin mining will be a crucial part for net stability all over Europe.
Very interesting. In that case, Bitcoin is the byproduct, and we're moving toward that. Like mining is an energy tool instead of a end goal by itself.
Yeah, it's mind blowing for me as well. I've been in this since it was 12 point, what was the block reward? 12.5 was it? Then 6.25, yeah, now 3.125. And every time the same thing happens, we all want their same customers are also thinking or wondering about, what will happen when the block reward gets divided in half? Will we be profitable at all? And every single time there are major shifts happening, not only in Bitcoin mining, but all the technology, how we mine, and the infrastructure. And with the infrastructure, also the image of Bitcoin, I would say so. It was, first of all, it was dirty coin, like really dirty. People used whatever was the cheapest source of electricity. And I know some large companies were also buying coal mines just to mine Bitcoin at scale. It has shifted from that. We're becoming more greener, more flexible, more society friendly. And I think that's a good sign.
So basically you split mining of the future into, or at least in Europe, into 2 parts. One is the grid balancing and the other is the heat reuse. So can you tell more about that heat reuse part and what Power Mining is doing there? And what do you think is the future of heat reuse in mining?
Great question. We've been thinking about this for the past maybe 2 years. Last year, we started working on a project for heat reuse, and we started it from a perspective of not Bitcoin mining, but the perspective of energy companies, the ones that are using actually or producing some heat and giving to the city. So that was a bit different take. And we also then, let's say, hired another engineer who helped us develop the proper cooling as well as the heating part so that all the systems work together beautifully. And for them, everything was clear from the piping part, but they had no understanding from the data center part. And we, on the other hand, had no understanding of the heating part, but we had all the understanding and experience about the electricity and the data center part. So when we combine all of these things, it came out to be a beautiful product that is useful, I would say, in any country that needs warm water. You know, with the latest technology, it's now possible to deliver heat starting from 60 degrees on the outlet. Starting from. So 60 until, let's say, 75 degrees, you're pretty comfortable of being able to supply most of the heating grids in Europe, at least the first level. Maybe also for the bigger purposes or more industrial, you would need another heat pump, but that still gives a lot of benefits to heating companies. And they're looking at it differently. First of all, curious, but not really certain about Bitcoin. But then again, if you skip the part about Bitcoin and just say, hey, forget the first part, we will be delivering you, let's say, 70 degrees constantly. What will you pay me? And then it's an easy conversation.
Yeah, it's maybe the biggest mistake of many miners when they talk with energy guys is to focus too much on Bitcoin, because that's just overcomplicating everything. In reality, it's quite simple, like you explained. So I saw that there is a YouTube video that Joe Nakamoto posted. He visited your container, the heat reuse container. It's very interesting for listeners. You can go and watch that video on YouTube. Very, very, very interesting. So, Janis, do you have deployed that this container? Like, is it producing heat in some district heating site right now?
Yes, it is. It's delivering around 60 degrees now, but it's not the limitation. It's the requirement of local municipality. Basically, at that point, there's also the backup dry cooler on top that cools the rest of the heat. But this solution can be applied, as I said, basically to any location where you need warm water. And that would be probably all the countries in Europe, even Spain and some regions, which sounds unbelievable, but it may be very true. It was interesting that that part was presented in the previous conference in Riga, energy conference, and a company ABB approached us and said, you know, guys, it sounds very interesting what you're doing. Can you tell us more? So we had a few meetings. It's a large company, you know, ABB, and they said, yeah, can we include your story in our this year's presentation, because this sounds that it's going to be the future. And the funniest part was that all good. We presented them with few facts, you know, what they can present, that we can get like 75 degrees on the outlet temperature, very high efficiency, the power usage efficiency also like very low unless you need the dry cooler. There's basically no auxiliary systems except the pumps. So basically all of it goes directly into heat. And then after presenting all these wonderful numbers, and the heating companies were looking at, wow, this sounds really interesting. And I saw the crowd there. They were all curious about the data that company ABB brings out. And there is way more weight in the presentation that company ABB does it, not us, you know? And there was no mention of Bitcoin. It was just mentioning data centers, HPC in general. So the next company that presented their data center heat reuse was Microsoft, that presented that they can get about 30 degrees heat reuse. And the energy companies were like, what? Like our back loop is like 40 degrees. So it means we would just have to cool it down further just to match your requirements. So it made
I saw, I think it was in Finland and Sweden as well, that Microsoft, Google, like these huge data center traditional companies, they are using the heat and they're very proud, and they can only deliver like 30 degrees. Is that what you're saying?
yeah.
But what is the point of that? Like, does
No,
it really make a difference?
no, I think that is just a marketing thing where they can take the sustainability check because it brings no value to nobody.
Yeah,
But
because the unique
however,
thing about mining is that you don't need a heat pump to bring up that temperature even further.
yeah, in some levels, at some points, yes. In some, it's still needed, but it's depending on the customer, the municipality, on
What
a
do you
lot of
think
things.
is I know in Finland, heat reuse is very popular for mining. You said Latvia, energy companies, they're interested. Whole Eastern Europe is like very cold and traditionally heated by natural gas systems. So what do you think in general, like are the future regions for mining heat reuse? And do you think, I know you're going to say Europe, but do you think like Canada or US is also a potential place?
Yes, definitely. Like everywhere where you need the hot water, that's what it does. It can heat up water significantly and without any maybe even additional costs. What it may bring you long term is lower the heating costs in general, because you may need less. I don't know what you heat it with, but definitely gas is a huge problem in Europe, right? Not all countries in Europe have gas. Basically, only Norway has it, or or at smaller scale, some other countries as well. But mostly, it's not available. So gas has always been imported from the east, which is now a big issue. And I think now also south is becoming issue. So we're only left with west, but there are only limited amount of gas tankers in the world. So there's a bottleneck. There is a huge bottleneck for gas. Wood is good. It's definitely renewable. It has CO2 emissions, but it's more expensive. So I'm not saying that Bitcoin will be the only source or data center heat will be the only source. No way. But it may be a significant part in all of this infrastructure, because we also have to take into consideration nowadays, even if AI data centers will be achieving something like that on the outlet temperature, something similar to Bitcoin mining, they will never be as flexible as Bitcoin miners. Never. They have to, they're battling for 6 digits behind the zero, for uptime. It's like 99.9999. Do you get the seventh number is 2 or 6? That's what they're battling about. As a player in energy markets, they are very stable and reliable, but they would never be able to switch off. That means you need a consumer of that heat throughout the year. And those are limited amount of locations in the world that you may have to need so much heat.
Yeah, but when we talk about the heating demand throughout the year and how you scale the mining operation dependent on that, I know at least in Finland, the common way to do it is to, let's say that peak heat demand is 10 megawatt in a small town, but in the summer, like the base heat demand in the summer when it's the lowest demand is maybe 2 megawatt. So then you scale the mining site at exactly 2 megawatts so that it can provide that base throughout the year and you never have to shut off the site.
Yeah.
Isn't that what is common in Europe as well, like Latvia, for example?
There are base loads, yes. But then again, it might be that you may need to switch it off at some point, right? As a Bitcoin miner. So even though it is a base load, it's one of the players on the market. So what I'm trying to say here is that AI can't do it. They're not aiming for 10 or 2 megawatt sites. It's not beneficial for them. It's not possible. But
Yeah.
Bitcoin miners can do that. They can be at a smaller scale. They can be decentralized. They can be scattered around like on the highway every 10 meters. That can be done by Bitcoin miners, but it's never going to happen with the AI or conventional data centers.
Yeah, so essentially, when it comes to data centers, because Bitcoin mining is just such a simple process and demands so little of the infrastructure compared to other data center processes, it becomes like the energy tool, while the others are more a purpose by itself. Like AI is
Yeah.
just purpose by itself and you just run that. But in mining, you will have to integrate it with energy systems and provide some value in different ways. You talked about also, first we talked about grid balancing, then the heat reuse, and you mentioned that you can also do both at the same time, right? And that must be the Bitcoin mining on steroids, right?
Yes, but that is what the system permits it. How you structure your business, like which is the main focus of your business? Is it Bitcoin, electrical energy, or heating energy? That's kind of already, every single location probably has its own sweet spot, where you focus on. Is it the heat sales, or is it uptime, or is it up peaking plant, something like that? So you're given three tools now in three different markets. It's a unique combination that you can do.
And how can you do grid stabilization while at the same time producing heat? How does that work? Because then you have to shut down your machines sometimes, but at the same time, the heating system need heat, and maybe you have a commitment to sell them heat. So how can you actually organize that in practice, delivering heat and do grid stabilization?
Most likely not, unless it is, as you said, let's say an example, a city needs 10 megawatts constantly in winter, but 2 megawatts constantly in the summer. Then basically, if you have the power purchase agreement for 10 megawatts, then still the 2 megawatts have to be running constantly throughout the year, but the rest 8 you can play around with, and depending on the season. But yes, as I said, the tools are there, but how you structure it is basically your business and which is your focus,
What machines are the best for heat reuse?
Ooh, that's a great question. It's a great question. What we've noticed, I think the most popular one is MicroBT, the Watts Miner M63 something, and now the latest M70 series is coming out as well. I'm not sure about the temperatures. There's a promising company, which is Auradine from the US. I like to mention them always because they are the black swan in the Chinese dominated market. They're a US company. They are bringing some interesting features. I hope they do succeed because they are also manufacturing the chips, ASIC chips. But when we're talking about heat reuse, I don't think it's really the brand that is now, okay, today it is the brand that is determining this, but the future lies in the brand which will develop chip most resistant to high temperatures. So previously it was always about cooling the chip. Now it is about chip not overheating at 110 degrees, let's say. So it's a different technology. I'm not a physicist. I can't tell you if it's possible at all or not. I don't know how. I've seen how chips are built, but it's a complex process.
Do you have any closing thoughts on mining infrastructure or heat reuse, grid balancing, whatever?
Yeah, guys, buy Bitcoin.
Betting on Bitcoin is not gambling.
Mr. Saifuddin Anonymous confirmed. He personally confirmed and said, yeah, this is profound. Now, but if we're talking about mining, I think the market dictates the developments. What we can do is try to be ahead at least one step and say, hey, we have thought about this. And it is what we do constantly. We see some developments in some areas and we start moving towards that. And why we are in Europe, one of probably top companies for this, is because we've never manufactured anything outside of European Union. We still like to maintain the quality. We still like to maintain the quality control that we can oversee, that we can also trace. All the components, like the PDUs, are made by us here in Riga. These miners are also made here. Of course, chips are not from Latvia, but the rest components are not components, but the manufacturing, some parts coming from China and something from Texas Instruments and all over. But altogether, that's our focus. Everything that is needed for mining infrastructure, heat reuse, grid balancing, that's, I hope. Hey, call us.
So, Janis, thank you very much for joining the podcast. And before you go, where can people find you and Power Mining?
It is a website, powermining.io, powermining.indianocean, or LinkedIn, to me personally or the company.
Okay. It will be in the
Janis,
show notes. Thank you very much for joining, Janis. It was a great conversation.
thank you, Jaran, for having me. Reach out anytime. Ciao.
Bye-bye.